Hi, I am Aniket and in this video I will be showing how I have done the credit risk analysis project using Power BI. So to build this project I went to get data, then select text and CSV and used this credit risk dataset CSV file. And this credit risk dataset CSV file is having person age, person income, person home ownership, person employee length, loan intent, loan grade, loan amount, loan interest rate, loan status, loan percent income, and person default rate on file and person credit history length. Actually, this dataset is showing the loan information about the persons who have taken the loan. And to build this project I have went to transform data to use the Power Query, and from here I have ensured that each and every column is doesn't have any duplicate or any empty or null values. Sorry, I have ensured only the columns shouldn't have any duplicate, sorry, on null values. Now I have several questions to build this project. The first question is, using DAX I have to calculate the average loan amount and the average interest rate for each loan grade, and I have to calculate how these metrics correlate with default rate. To do this I have used average function to calculate the average interest rate, and again the average function to calculate the average loan amount, and I have shown how the average loan amount and average interest rate according to each loan grade. Next I have calculated the default rate using calculate divide, count rows and all except. The calculate function here is calculating the division of the count of all the rows that are having loan status equal to 1 divided by the count of all the rows of credit risk dataset, and for each and every loan grade of the credit risk dataset. And to show the correlation between average interest rate, average loan amount and default rate, I have used this scatter plot that is showing the correlation between these metrics. I have also used this trend line to show that the higher loan grade typically have higher average interest rate, and this may correlate with higher loan amount. In the next question, I have to create a report by visualizing the distribution of loan status across different employment lengths and home ownership status, which combination shows the highest default rate. To create this visualization, I have used this clustered bar chart and used the loan status in the y-axis and person employment length in the x-axis and the loan status in the legend section. And this is showing the count of loan status by employment length. And to visualize the loan status by home ownership, I have used this pie chart, and in the legend section of the pie chart I have used person home ownership, and in the values section I have used the count of loan status and default rate. I have also created the person home ownership slicer and the person employment slicer to vary these visuals according to the slicers. In the next question, I have to segment the borrowers by loan intent and visualize the average income and average loan amount for each segment, and have to find out which intent has the highest loan amount to income ratio. To segment the borrowers by loan intent, I have used this clustered column chart, which is having loan intent in the x-axis and average of the person income in the y-axis and average loan amount in the y-axis. This clustered column chart is showing the average income and average amount by loan intent. In the next clustered column chart, I have used loan intent in the x-axis and loan amount to income ratio in the y-axis. And to find out the loan amount to income ratio, I have used this DAX function, that is calculating the loan amount to income ratio. So from this visual, I can clearly say that the home improvement intent has the highest loan amount to income ratio. In the next question, I have to consider CB person credit history length as time dimension and analyze how loan default rate has changed over the years and implement a time slicer to adjust the viewed period. For this, I have taken this line chart that is having year in the x-axis and sum of the default rate in the y-axis. And to calculate this year,